In this video, we'll be looking at the power rule. Now, some of the questions that we'll be answering in this video includes: what is the power rule and how do we use the power rule to differentiate functions? Now here we want to look at the power rule and how do we use the power rule to differentiate functions. Now here we have some functions examples and we're going to differentiate all of these using the power rule. Alright, so what you guys can do, you guys could attempt these 6 examples, alright, and then resume the video and watch for the correct solutions. Alright, now according to the power rule, if y is equal to x to the power of n, then the differential of that would give us nx to the power of n minus 1. Alright, so what that simply means, you will multiply the power by the x, then you will subtract 1 from the power. Alright, as we are seeing here. Now let's look at this thing from the perspective of some examples. Alright, so if we should differentiate question 1, y is equal to x to the power of 4, then this thing would give us dy by dx, alright, would be equal to, now we'll multiply this function by the power, so we'll end up with 4x, alright, so multiply the function by the power, 4x, then we'll subtract 1 from the power, 4 minus 1 would give us 3. Alright, so that's pretty much all to that. So it's pretty easy to use a power rule. Let's look at example 2. Now, looking at this one, dy by dx, so the differential of this thing, dy by dx would be equal to, again we multiply the function by the power, so 3 times 2, that would give us a 6 right there. So we have 6x and then we subtract 1 from the power, 3 minus 1, that would give us a 2 right there. Alright, so the differential of 2x to the third power is the same thing as 6x squared. Alright, so let's look at this one now. Alright, so if we want to differentiate this thing, so dy by dx would be equal to, and by differentiating this thing, what we'll do, we'll differentiate each term. Alright, so here we know that what, we'll multiply this thing by the power, so 2 times 4, that would give us a 8 right there. So we'll have 8x. If we subtract 1 from this power, we'll end up with x to the power of 1, which is the same thing as x. Alright, now if we should differentiate this negative 8x, then pretty much we'll have something, let's say we have a function being equal to negative 8x, then dy by dx would be equal to, now negative 8x is the same thing as negative 8x to the power of 1. Alright, so we'll multiply this thing by the 1, that will remain 8x. Alright, so we'll have 1 minus 1. So this is the same thing as saying negative 8x to the power of 0. Anything raised to the power of 0 is 1. So this is the same thing as negative 8. Alright, so if we should differentiate negative 8x, we'll get negative 8. If we differentiate any constant, the derivative of any constant gives us a 0. Alright, now here we have example 4. So we have y equals 3x plus 4. Alright, so dy by dx would be equal to, if we differentiate this thing, the same thing applies just as if we had the negative, 8x up here, as we explored that before. So once we differentiate this x term here, we'll only be left with 3. And remember, once we differentiate any constant, the result is always 0. All right, so the derivative of 3x plus 4 would give us a 3 right there. All right. Now let's look at question 5. Now, the derivative of this thing, dy by dx, would be equal to, again, we multiply this thing by the power, so negative 3 times 2x, that gives us negative 6x. If we should minus 1 from this power right here, we would have negative 3 minus 1, and that would give us a negative 4. All right. Now here we have the final one, which is question 6. All right, and this is y equal 8 over the square root of x. All right, so let's look at what we want to do with this. Now, before I even go into that, let's rewrite this thing. Let's rewrite this function. So this is the same thing as y is equal to 8 over x to the power of a half rather. All right, so 8 over the square root of x is the same thing as 8 over x to the power of a half. Now we can also rewrite this thing as, we can bring up the x to the power of a half in the numerator, and we can get 8x to the power of negative a half. All right, so this is the same thing as saying y is equal to 8x to the power of negative a half. All right, and we can treat with this thing now. So dy by dx, this is easier to work with. So dy by dx would give us negative a half times 8x would give us negative 4x. If we should minus 1 from negative 1 over 2, that would give us negative 3 over 2 right there. All right, and this is pretty much a differential of 8 over the square root of x. All right, now if we wanted to apply a little bit of indices, we could write this in a simpler form if we so choose to. You don't have to, but we could also write this as dy by dx equal negative 4 over the square root of x cube. All right, so if you are comfortable with indices, you could do that. All right, but that's pretty much how you use the power rule.